All right, Khan Academy. So I have mine up in front of me, and hopefully we have the same one, or again, it's a disaster. So my first one says, what is the integral from 1 to infinity of e to the x dx? So unfortunately, it doesn't look like what we've been talking about. Khan Academy is weird sometimes, but that's okay. We should still look at it. So because it's not the p-test, I don't know if it converges or not. So I'm going to have to change this to the limit as n approaches infinity of the integral of 1 to the n. Oops. Let's get this integral. The integral of e to the x is just e to the x from 1 to n. So we're going to plug in, so we're going to have e to the n minus e to the first. And now we got to look at the limit. So as n approaches infinity, you're really just asking yourself what's happening to this term, and we already know what's happening to this term. This term is going to be e. When I plug infinity in, I'm going to get e to the infinity, or I have to think about what is that? Well, that is infinity. This cannot be my answer. Once one part goes to infinity, the whole thing is going to go to infinity. Taking infinity and subtracting out e does nothing to change the fact that this is infinite. So if I ever have infinity plus or minus like some number, the answer is infinite, and the integral is going to diverge. So this integral diverges. Correct answer is D. Okay, now we've got the integral from 0 to 1. Oh, I didn't even show you this. Let's see what happens. I don't like this. I don't really want you to have to go through this one, but let's just see what happens and see if it's easy enough for us to do with just the information that I gave you. So you don't have an infinity here anywhere. But this is still improper because plugging in 0 to this is going to give me a problem. So I still am going to have a limit as n approaches 0 from n to 1. I'm going to take that 0 out, and I'm going to technically approach 0 from the right. So I'm going to technically say, what's happening as this graph approaches 0 to the right? I don't really want you to get mired down in this, but let's just see what happens. Let's change this, x to the negative 1/2. Let's do this integral out. So we're going to have x to the positive 1/2 divided by 1/2. So we're going to have 2 root x. So, from n to 1, so we're going to have 2 root 1 minus 2 root n. And what happens? 2 root 1 is just 2, minus 2 root 0 is just 0. So the answer should be 2. We were able to calculate it anyway, even though we really didn't know what we were doing, or we didn't really see one like this. It's okay, the same method still applies. The problem in my limits of integration was not 1. The problem is 0, because 0 is going to give me a denominator that's undefined, or a denominator of 0. So I'm taking the 0 out, replacing it with a variable, and changing this into a limit problem. Then I'm going through, blah, 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 and I end up getting 2. All right, that one's not as important. Let's check out number 3. Okay, number 3 is good. They're giving me a negative infinity to 1, but it's okay. My rules should still apply. So the integral from negative infinity to 1 of 3 over x squared. Let's take out the infinity, or negative infinity. Brought that up at the same time. Leave the limit, do the problem. So we're going to have 3x to the negative 1 over negative 1. Add 1 to the power, blah, blah. So this is going to be negative 3 over x. So let's plug in 1 minus plug in n, and let's evaluate. So n is going to negative infinity. It doesn't really matter that it's negative infinity or positive infinity, because it's going to make this entire fraction 0. So I'm going to have negative 3 plus 0, which is just negative 3. Oh, it said try again. Why did it say that? Is it 3? It's 3. I wonder why. Oh, right, okay. Yeah, that's a little tricky, huh? I wonder why that didn't come out as positive 3. Other than I have to think about what it looks like. So 3 over x squared looks like this. So the area from negative infinity to 1, or to negative 1, sorry. Oh, that's why. Ha! There we go. Negative infinity to negative 1. So I'm actually plugging negative 1 in for this is positive 3, positive 3. Okay, good. Because if you do look at the graph, here it is. All that area is above the x-axis, so I do get positive 3. Okay, good. And then my last one. Oh, notice on this one, by the way, that power was bigger than 1. The p-test says as long as that power is bigger than 1, we should have a series that converges. And it did. Now look at this one. My power is 1/3. I should get a divergent series. It's a good idea to go through it anyway, the work, just to get the practice of this. But let's say, 0 to 8. I swear I can't see. Okay, so what's the problem here? And like, if I didn't see that this was improper, right? When 0 goes in here, I'm gonna have a problem. It's really, honestly, between us, not the end of the world. So I can kind of go about doing this without the limit. I technically can. I'm supposed to put a limit in. I didn't even want to really tell you this, but I feel like you're gonna stress out otherwise. If you never even put that limit thingy in, this is never gonna be an open-ended question. So if you didn't put the limit in, and you were just kept this in as 0, and you were just cruising along doing the problem, not realizing that 0 was gonna give you an issue. Let's just see what happens. So this would become x to the, add 1 to this, divide by the new power or multiply by its reciprocal, from 0 to 8. I should get diversion, right? X to the negative 1/3. But even if it was a limit question, oh, all right, this one doesn't diverge actually. So that p-test, see, I'm learning as I go along. Okay, let's finish it. So I have 3/2 times 8 to the 2/3 minus 3/2 times 0 to the 2/3. So 8 to the 2/3 is 4. I'm gonna get 6 minus this is gonna be 0, so I should get 6. Let's just check it. That is correct. Okay, so I didn't really put this together, but I guess the p-test is only going to be applicable when I have from 1 to infinity. Yeah, that totally makes sense. Why would I think the p-test applies here? It does not. So that's only going to be when I'm going all the way out to infinity. So if I had 1 over x to the 1/3 from 1 to infinity, this would diverge. This would equal infinity. But I only have from 0 to 8, so I'm working on this much more condensed and small space, and it ends up working out to be 6. Look at that. Cool. All right, tomorrow we'll probably do a little bit more practice, but hopefully you're feeling okay.